All right, welcome everyone to the Natural High Intensity webinar with a focus on monk fruit and stevia. My name is Alina Hildebrand. I'm a product manager here at ChemPoint for the Tate Lyle High Intensity Sweeteners. Just a little bit about ChemPoint before we get started here. We are a distributor of specialty ingredients, and we have been a strategic partner with Tate Lyle for the past 10 years on their high intensity sweeteners. So today I'll start with a quick introduction of our guest speakers, followed by a 45-minute presentation by Tate Lyle, and then we'll close this webinar with a 15-minute Q&A session. So here today with us from Tate Lyle, we have Alison Furiossi, who is a product manager for high-intensity sweeteners. Alison has been at Tate Lyle for 5 years. Also with us today, we have Ileana Nava, who is the technical service for the North American team at Tate Lyle. Ileana was a former tech service for Mexico, Central America, and the Caribbean. A lot of information will be shared today through this webinar, so I encourage everyone to take notes and ask questions. At the top right corner of your screen, you have a toolbar for you to type your questions, and we'll address them at the end of the presentation. This webinar will be recorded and we'll make sure to make it available to you. Once the presentation starts, we ask that you either enter your audio PIN or that you mute yourself to prevent background noise to bother Ileana. And with that, I will hand it over to Ileana. Ileana, all yours.
Hi everyone, thanks Elena, and thanks everybody for your time and your attendance today. So I'm going to walk you through the agenda a little bit. I'm having some trouble switching the slide right here. There we go. All right, so our agenda for today, so Elena already introduced herself. We are going to talk about Stevia and Monk Fruit, and the commercial names of these products from Tate Lyle are basically TASTEVA and PUREFRUIT. So we're going to walk you through the product characteristics, some examples of products that are currently on the market, and we're also going to share with you how we approach some formulations with TASTEVA and PUREFRUIT. We're going to show some examples of beverage and bakery applications, and an example of cost in use with both TASTEVA and PUREFRUIT. Finally, we're also going to mention how to work with PUREFRUIT as a flavor, in the case of flavor houses, considering the FEMA regulation, and in the end we're going to have some time allocated for Q&A. So PUREFRUIT and TASTEVA. First of all, I would like to start with a general introduction, mainly of the differences between nutritive and high-intensity sweeteners. So as the name says, a nutritive sweetener is going to provide that source of energy. It is a carbohydrate, so it's going to be metabolized and absorbed by our bodies, and it's going to be a source of energy for ourselves. So in terms of the products that Tate Lyle handles, we have fructose, which is a crystalline product, powder product. Then we don't manufacture sucrose, but we have it stated there because it is going to be our sweetener of reference. So it is what we are used to in terms of sweetness. So everything, all of the potencies of high-intensity sweeteners and of nutritive sweeteners as well are going to be referenced back to sucrose. Tate Lyle manufactures high fructose corn syrup, maltodextrin, and dextrose on the side of the bulk sweeteners platform, and finally allulose, which is low-calorie sugar. So all of these products are going to provide energy. And then high-intensity sweeteners, such as sucralose or Splenda for Tate Lyle, and other sweeteners like aspartame, neotame, saccharin, acesulfame K, and then the natural ones, Lohanguo, which is a PUREFRUIT, and TASTEVA, which is a stevia or stevia sweetener, are not going to be considered a source of energy. So these are not going to be absorbed and metabolized by the body. These are going to be mainly used for sweetness, so to sweeten products. So also for your reference, here I'm stating some of the relative sweetness of some of these ingredients. And again, I mentioned sucrose is going to be our reference, as you may already know. So we have some examples there of relative sweetness of cyclamate, and then the natural ones, of course, Lohanguo and stevia, acesulfame, aspartame, saccharin, sucralose, and neotame with different relative sweetnesses compared to sugar. So how much more sweet are these ingredients compared to sugar? And then we have there that potency. It is dependent on the application, right? So we have to consider that these ingredients oftentimes are going to be included in a matrix of different other ingredients and are going to be interacting in terms of flavor and sweetness with these ingredients. So depending on which food product or in general product we're going to be using these sweeteners is also going to affect the potency of the sweetness. If you want more information about this, there are these couple of books that I have under in the bottom of the slide. The Sweetener book, mainly by Eric Walters, and then Sweetness and Sweeteners. If you are already well versed in the sweetener world and want to go back to the basics, these two are really good books. Or if you're starting to work with sweeteners, I highly recommend these two as reference. So let's focus on PUREFRUIT, which is the monk fruit extract. And there I have an image on how the fruit actually looks like. It is very much the size of a kiwi, so it's like a small. It looks like a small melon. It is actually of the same family of a melon and cucumber, and it is considered a national treasure in Asia, and it has been used to sweeten certain infusions and products for centuries. It is 150 times sweeter than sugar on average, and it has a significant preference versus Rebaudicide A. It will provide a clean and balanced sweetness, no bitter aftertaste. It is going to minimize the need to add flavor improvers or masking agents. And in terms of sweetness development and how it performs in a product, is going to have a slight delayed onset of sweetness compared to sugar. And I have a couple of graphs later on in the presentation in which I'm going to explain this with more detail. The process that is used to manufacture this product, it is a proprietary technology that allows to deliver this improved taste of monk fruit. And in terms of label benefits, it allows the use of this claim that says natural sweetness from monk fruit or from fruit. So monk fruit has a very clean and sweet taste, as we mentioned, with a slight delay of sweetness and a slight linger of this sweetness. So it's going to be delayed and a little bit of a linger. And again, depending on the application, you're going to see that the potency varies from 150 to 250, the sweetness of sugar. It is very easy to use. It comes in a powder form, so it's readily soluble, about 30 to 35% of solubility in water. And it is suitable for use in combination with other sweeteners. In terms of labeling, we have that it can be labeled as monk fruit extract or monk fruit concentrate, or if you want to use its name in Chinese, which is actually, so Lohan Guo means monk fruit, so you can also use that. Lohan fruit extract or concentrate, or Lohan Guo extract or concentrate. Those are also options. So how it is produced? As I mentioned, we use a proprietary technology, but in general terms, what we do is we grow and harvest the fruit. And then what we want to do here is we want to concentrate the inside of the pulp or the fruit, because we want to obtain the sweetness molecules. In this case, in the case of monk fruit, the molecules are mugrosides. And the molecule that is going to provide that characteristic sweetness of monk fruit is mugroside 5. So we're going to crush the fruit, infuse it, filter it, so concentrate it in order to obtain that molecule. And finally, we'll spray dry it in order to obtain that powder form of the product, which is later packaged and distributed. In terms of stability, we performed this test to show the stability of monk fruit at different pH values. And in this case, we used just a model system of basically acid and water. And we stored the solutions at 40 Celsius for 6 months. And actually here we have different other temperatures. So 55, 35, and 40 Celsius for 6 months. And what we did is to evaluate the percentage of mogroside 5 remaining. And in both cases, at a low and mainly acidic, acidic and neutral, closer to neutral pH, we observed that there were no significant changes in the remaining of mogroside 5. Then we also did the same evaluation in an actual application, and in this case we used two types of beverages, so one cola beverage and one flavored water. The cola beverage with a pH of 3.4 and the flavored water with a pH of 3. So highly acidic products. Also considering two temperatures and a storage time of 6 months, and the remaining of mogroside 5 was highly stable. In both cases, there were no significant changes. Monk fruit is also stable to pasteurization, or in this case to heat treatments, to high temperature processes. We did an evaluation here at 85 Celsius for 30 seconds, so a regular pasteurization in the flavored water, so the product with a pH of 3, and we didn't see any changes before and after pasteurization in terms of parts per million of mogroside 5. So I'm going to move on and talk about TASTEVA. So stevia is it's a small shrub. You know, it comes from a leaf that was originally discovered in the region of Paraguay, so in South America. And this plant has been renowned by natives for its unique sweetening power, so also used as sweetener for infusions and some other food products. It has a relative sweetness of 200 to 300 times of sugar, and it also has a significant preference versus Versatility A. It has a clean sweetness, also no bitter aftertaste, and I'm going to explain you a little more about this, how this TASTEVA was developed. It minimizes the need for flavor improvers, so just because it doesn't have this bitter aftertaste, you will not need to use any masking agent, any flavor improver. It also has a slight delay onset of sweetness, so similar to monk fruit, and the proprietary process allows us to provide the optimized steviol glycoside compound. It can be used, so we can use this claim of naturally sweetened when using TASTEVA in a food product. TASTEVA has, as we mentioned, a sweet taste with a slight delay of sweetness, and also, well, very similar to monk fruit. The potency is of about 250 to 300 times of sugar, so depending on the application, and it's going to have these benefits of providing no calories, this clean and upfront sweetness, and highly stable to heat treatment and low pH product. So I'm going to talk to you a little bit about how this TASTEVA product was developed. And we're starting on with this challenge of use of some Versatility A products, right? So we know that sometimes it is challenging to sweeten products with Versatility A. Sometimes we have to use more than one Versatility, maybe 2 or 3 of them to achieve certain sweetness perception. But in this case, what happens is that we know that, so it is challenging to use, and over about 80% of consumers are moderately to very bitterness. We have, in this case, so there is, and this is something that we evaluated internally, there is this segmentation of bitter tasters to moderately sensitive. So we have that 40% of the tasters were moderately sensitive, then 43% very sensitive, and 17% didn't perceive any difference in terms of bitterness. So whenever you gave them a sample, they wouldn't be able to tell if it was bitter or not. They just basically tasted the sweetness of the product. So what happens with Versatility A is that sometimes when you want to increase that sweetness, you want to use more of Rev A. But what happens is that you not just increase sweetness, it also increases in bitterness. So again, this makes you want to use something else like a masking agent or maybe a erythritol, and this is just going to add up to your cost. And it is also going to actually limit the use of Versatility A and sugar replacement. So for some products, you will only be able to reduce up to 25 to 30% sugar using Versatility A. So what we did in Tate Lyle was to evaluate different samples of steviol glycosides, different molecules, and we selected the ones that provided the best sweetness characteristics without that bitterness. And the objective was to minimize this bitterness to be preferred by 83% of these consumers that were identified to be moderate to very sensitive to bitterness. And also, thanks to this selection of steviol glycosides, we will be able to reduce a higher amount of sugar, so 50%, maybe more, depending on an application, and of course with a clean and improved taste profile. So TASTEVA these are some of the most common examples or applications in which TASTEVA is used. So juice drinks, flavored waters, sports drinks, so mainly in the beverage category is where we will mainly see stevia, but also in some other products like dairy products, snack bars, cereals, candy, ice cream, etc., which are not maybe the most common applications, but it can also be used in these other products. So again, being able to replace up to 50% or even more sugar, depending on the application, with this natural halo. So synergy. This is a very interesting one. So when working with sweeteners, and maybe if you have done this already, you already know that some blends of sweeteners are going to provide a higher sweetness. So maybe you will be able to use less of that blend of sweetness. And in this case, we're going to evaluate the synergy of TASTEVA with sucrose and fructose. And in both cases, we're going to see how we are. So if we look at our x-axis in both graphs, we have our SEV, which is sucrose equivalent value. And we're comparing them as three different SEVs. So 5%, 8%, and 10%. And we stated on the title that we're using a 50-50 blend or 50-50 sweetness contribution of each sucrose and fructose. So in the case of the 5% SEV, we're using 2.5% sucrose or fructose, and the other 2.5% in sweetness is going to be provided by TASTEVA. And then the expected sweetness, which is represented by the blue bar, it is going to be of, very close to 5 or 8 or 10, respectively, but then the observed sweetness, so the sweetness that was actually perceived, was a little bit higher. So this represents that potency for use of less sweetener blend and of course cost in use. In terms of stability, TASTEVA or this stevia sweetener has also demonstrated to be highly stable. And we did something very similar to what we evaluated with monk fruit. So in a cola drink of a low pH, so an acidic product, in 25 weeks at ambient temperature, and it remained very stable, so there was no significant change. In this case, we evaluated the percentage of steviol glycosides remaining. And then we also evaluated its stability at heat treatment. So we pasteurized 2 beverages at 85 Celsius for 1 minute. One of them was a strawberry flavored water and the other was a raspberry flavored water. And we measured the percentage of TASTEVA before and after processing, and we noticed no significant change. In terms of what's currently on the market, we have been tracking over the past few years the behavior of some product launches in the market. And where in this case, stevia has been used most commonly, or the most. And on our left-hand side, we're going to focus only on the beverage segment. So you can see how beverages that are used as meal replacers have an 18% of the market, or launches in the market, followed by juice drinks, and then flavored water. And then you have, the rest of the beverage products, so energy drinks, beverage mixes, carbonated soft drinks, your sports drinks, tea, and other beverages, maybe dairy products, coffee, etc. And then you have some images for you to kind of see what type of products are using, what type of beverages are using stevia. All right, so then on our right-hand side, we have stevia launches by food segment. So in other products other than beverages, and mainly we have that other products, so mainly ice cream, other dairy applications are also considered in this other category. Is the second, and the first one is used as a sugar substitute, so as a tabletop. Those are the two main categories, but then these other products are also important. And then, of course, this is followed by the bakery category and the yogurt and smoothies category, and then the snacks and chocolate. So these are also other applications. Then, in the case of monk fruit, over 50 food and beverage products have been launched in the past few years. And there you will be able to see in which products monk fruit is being used. So it is being shown as a tabletop ingredient or tabletop product, also as part of bakery products, as a sweetener, in cereals, in protein bars, protein drinks, juice, beverages. And something important to highlight here is that monk fruit has the potency to help balance the flavor, especially when you're using, those vitamins and proteins that provide this bitterness. Monk fruit will be able to balance those flavors and reduce that bitterness of proteins and vitamins in some products. So that's another advantage, and that's why you see it in a lot of protein shakes and protein bars. So I also wanted to show you some examples of products on the market using a blend of both stevia and monk fruit, so that you saw in which type of products these are being used. So it is also very diverse. So no sugar added cookies, protein bars, muscle milk and coconut milk, protein drinks, carbonated soft drinks, juice drinks, dairy. So very, very different products. And I wanted to show you that because there is a potential to formulate with both and achieve a cost effectiveness. And so this is what we're going to talk about next. So first of all, when we're looking for a sweetener, we want to know what our customers are looking for, right? So we think about taste, first of all, because we want a food product to taste good, and also to have a good functionality, to be easy to use, easy to disperse and to solubilize, to be able to have some claims in the front panel or back panel. Of course, we focus on that cost in use, and in that consumer appeal that relates to labeling. So we want the product to be label friendly, easy to pronounce, easy to recognize by consumers, and both ingredients, monk fruit and stevia, have this potential. So we also want to consider these additional things. So of course we talked about potency and intensity. That's the main thing that we look at when we're going to work with high-intensity sweeteners in general, and in this case with natural high-intensity sweeteners. And of course the perception. So when you calculate the amount of high-intensity product that you're going to use, you have to evaluate it to see if that's the actual sweetness that is perceived in your final product, because we have to remember that monk fruit usually interacts in flavor with some other compounds or ingredients in a formulation. So there might be a need for certain adjustments up and down depending on what is the food product, and of course what's the sugar replacement that you want to achieve. Then sweetness synergy, we mentioned a little bit about that as well. If there is a potential to reduce the total sweetener usage, that's something that we want to evaluate if we're using, depending on the type of other sweeteners that we're using. And then of course the flavor of the finished product, there are some flavors that are going to be enhanced by monk fruit and TASTEVA, like chocolate, fruit, some strawberry, etc. And of course the total solids content of the formula. And especially when removing sugar in some applications, we might want to add a bulk agent to bring back that volume that we took out from sugar. So basically, here we're going to look at some examples, and there are like the most common ingredients to do this are maltodextrins and some fibers, but again, we want to balance our sugars and our calories. So we're going to talk about some examples as well. All right, when I mentioned sweetness profiles and how monk fruit and TASTEVA have this slightly delayed onset of sweetness, I was talking about these graphs. So here we have, of course, fructose, sucrose, and dextrose as our reference. And actually, our main reference is going to be sucrose. So we are comparing them in terms of intensity of sweetness over time, and we'll be able to see the different sweetness profiles of each ingredient. So fructose is going to provide a higher peak of sweetness, and it's going to, let's say, it's not going to last too long. Then dextrose doesn't have that high peak, but lasts a little longer. And then sucrose doesn't have that peak, but has like a lot more of that sweetness, and it lasts a lot longer. So looking at this green sucrose graph and thinking about monk fruit and TASTEVA, the sweetness of both of these ingredients is going to be shown if we imagine that the graph was there. It's going to be a little bit shifted or switched, I'm sorry, to the right. It's going to shift a little to the right. So that's why it's going to be slightly delayed, and that linger of sweetness as well. And then there are other profiles on the couple of graphs in the bottom of acesulfame K compared to the other three sweeteners. And then the graph with the star is the actual profile that we want to achieve with either a blend or a single sweetener. But the goal here is to make it the most similar to sugar as possible. And here I'm also adding, very similar to what we did with the sweeteners, but with some acids, because sourness is another characteristic that is going to help us round and balance our flavors in certain applications, especially beverages. So there we have some examples of different acids and their sourness intensity over time. So we have tartaric, citric, malic, and lactic. And basically citric and malic are the most common acids. So we developed this specialized method to evaluate natural high-intensity sweeteners. And we recommend you use this when working with them because it's going to give you a good idea, especially if the goal is to determine what the preference and sweetness between two mainly between two natural high-intensity sweeteners. And in this case, we're comparing TASTEVA with arabidoside A97. So it is important for the panelists to cleanse their palates before and during testing. So that's why we provide, water, maybe a 2% sucrose solution if they need to, unsalted crackers to clean their palate. And we are going to indicate them to taste the TASTEVA sample first. And what we did previously is to prepare a couple of solutions of TASTEVA and Reb A97 of approximately 20 to 50 parts per million. And we don't label them. Maybe you can use 1 and 2 because we don't want them to know which product they're testing or tasting. So we ask them to taste TASTEVA first without telling them what product they're evaluating. And we wait 1 minute before the next sample. So during this minute, we can maybe start a discussion on the sweetness of this product, how it is perceived, etc. And then we ask them to taste the other sample, in this case, Reb A97. And we're not going to tell them what sample it is. And then in this case, we're doing it this way because if the order is reversed, we've noticed that some Reb A97 products have this bitterness that will have this prolonged carryover effect over the taste buds. So it will kind of cover the taste buds and it will not allow to perceive the sweetness of TASTEVA. And so this is going to impact the tasting results. And after this, we're going to wait for 2 minutes And then we're going to ask panelists to vote on the preference and sweetness attributes. And it is recommended to conduct not more than 3 tests per session. So these are some of the examples that I mentioned, that I talked about previously. We have a peach-flavored green tea, and in this case we were able to achieve a 0-calorie beverage that is naturally sweetened with TASTEVA on this Stevia Extract. We are also using citric acid to balance the sweetness, and as part of the flavoring profile of the product. So 0-calorie beverage, and this product has about 8% of SEV, so about, this is calculating a sweetness of 8% sugar. Then this is another example of, in this case, a bakery application, and this is also for you to see how we manage the solids and the bulk ingredients that I previously talked about. So here we added TASTEVA only to provide that sweetness, and we were able to replace sugar and bulk it back with polydextrose and soluble corn fiber. And we did this because these 2 ingredients provide, so polydextrose provides only 1 kilocalorie per gram, and PUREFRUIT provides 2 kilocalories per gram. So we were balancing our total sugars and carbohydrates at the same time, not adding more calories than we need to. And of course, this also represents, so both of these ingredients represent an excellent source of fiber. And then we added one starch for extra texture. So this is an example of a beverage with PUREFRUIT. In this case, we were able to reduce sugar in order to achieve 90 calories per a serving size of 8 ounces. We are not using anything else other than monk fruit, and of course sugar. And it's considered to be naturally sweetened. So one more example of a raspberry lemonade. And then for the bakery example, we have this banana bread with PUREFRUIT. And in this case, we're also using Cristar. So remember how we can achieve certain synergies with Cristar and PUREFRUIT. And we were able to reduce sugars in this product. We also added PROMISOR, that is a soluble corn fiber, in order to bulk back that volume when we took out sugar. And we were able to achieve 50% of reduced sugar. And the total sugars were reduced by 33%. And also, well, since we were adding soluble corn fiber, this product is an excellent source of fiber. All right, so this is the example that I previously talked about of cost in use and working with TASTEVA and PUREFRUIT together. So in this case, we're going to consider our control as the 10 SEV, which would be the 10 sucrose equivalent value, right? And we're going to look at the top table first. So we have 10 SEV, so 10% of sugar in our control and our cost associated to that. Then let's think about reducing that sugar to 50%, so we would have 5% sugar, and the other 5% SEV will be provided by PUREFRUIT at 0.02%. And there we have, well, of course, we have a cost increase. And this happens most of the times when working with high-intensity sweeteners. We're going to see a cost increase, especially if we're comparing it to a sugar control. Then we did another reduction, another sugar reduction, so considering a 7.5 SEV, so 7.5% of sugar and 0.01 of PUREFRUIT to that sweetness, to have the same sweetness as the 10 SEV product. And of course, there's also another cost increase. So this is something for you to consider. And then when working with blends of PUREFRUIT and TASTEVA, we have the same approach. So we're going to look at the bottom table now. We have sugar at 10% with the cost associated to it, and then we have the same sugar reduction, so 5% sugar, and here we're using a blend of 40% TASTEVA, 60% PUREFRUIT. And if we compare both tables, there is a potential to reduce the cost in about 50%. And the same thing happens with the 7.5% SEV. There's also a cost reduction when using a blend of these two ingredients. And I also wanted to mention an example of TASTEVA versus Rebe plus erythritol. As I mentioned previously, sometimes there is a need of using another ingredient when working with Rebe 97 to try to balance that sweetness, the round, the flavor, etc. And so in this case, we took out erythritol. So we are comparing TASTEVA versus the blend of erythritol and Rebe 97. So erythritol in the control is used at a 1.25%, and Rebe 97 is 0.023. Then the same sweetness as the control is going to be provided by TASTEVA as a 0.027, and there is a potential to reduce costs in about 30% just because you don't need to use that erythritol. And I mean, you're not going to need to use another ingredient to mask any bitter flavors. All right, so just to walk you through some of the platforms of Tate Lyle and some of the ingredients that I mentioned, we have our texture platform, which is mainly formed by specialty starches, so modified, native, and some of these will be used in some sugar reduction projects, like the one that you saw, the bakery project, the bakery product that was sugar reduced. There was a need to add a modified starch for texture. And then there are some, in the Sweeteners platform are actually our PUREFRUIT and TASTEVA, and then sucralose also as part of the high-intensity sweetener platform, and Cristar and Dolce Prima. Cristar is our crystalline fructose, and Dolce Prima our low-calorie sugar. And then I also talked about stayalite polydextrose and promitor soluble corn fiber. These are part of our health and wellness platform. And then we also have a food systems platform, which basically make customized and tailor-made blends of mainly hydrocolloids and gums. And these are also going to be of good help when working with sugar reduction projects if extra texture or extra viscosity is needed. So in summary, monk fruit extract has a sweetness of 150 to 200, that of sugar. It comes from monk fruit and it's natural. It has very good heat and acid stability. And then stevia has a sweetness potency of 200 to 300 times that of sugar. It's also a natural sweetness from stevia, and it has very good heat and acid stability as well. So in terms of PUREFRUIT as a flavor, we have certain opportunities with flavor houses because, and I'm going to make reference to our FEMA regulation. Sorry about that. Okay, so monk fruit is stated on the FEMA GRAS regulation on the table 25. The category is 4711. And here we'll be able to see, and I apologize if it's too small, but we can provide you with this information if necessary. You will be able to see what are the maximum recommended amounts of FEMA for use as a flavor of monk fruit, and the different food applications in which it can be used. So there's also potential to be used for flavor houses as part of their sweetening system.
So thanks everyone for joining today. We just wanted to kind of summarize a little bit with another touch point that we feel is important and another kind of added benefit of working with Tate Lyle on these natural high-intensity sweetener products. So over the past few years, we've really focused on bringing new innovation to the marketplace. So PUREFRUIT and TASTEVA are two great examples of that, recent examples at least. But more importantly, we wanted to point out that we do protect our new innovations with our extensive IP portfolio. We feel our IP really helps make us a unique supplier and allows us to deliver a high-quality product to our customers. So particularly for PUREFRUIT in this case, that high quality is made possible through our proprietary purification process. So it's a unique process that results in the effective removal of those non-desirable components. So anything that can cause off taste or off flavor. There's some examples here on this slide of specific things that we remove, but then also anything that can deteriorate the product. So we took a lot of time and effort to really develop a process that's going to ensure that the highest quality of product goes out to our customers. So it's just something we wanted to point out. Our focus is delivering that high quality that's expected by our customers, but it's also out there to protect our innovations as well as your own. So we want you to be aware of what we have in place that can help you as you start to work with these products in your formulations, hopefully. So that's the last kind of touch point we wanted to have with the conversation today.
We appreciate everybody's attendance and time today, and we hope that this information has been useful for you. Again, if you have any question later on, or if you need any additional information from what we talked about today, feel free to reach out through Alina, and she will be able to provide that to you.
All right, thank you everyone for joining us today, and we hope that you found the presentation useful, and that will conclude our presentation today.